This is day 18 of Unit 4. So we just did a very short lesson today. So we'll get started with that. So today we talked about how to graph complex numbers on the complex plane and also how to calculate the absolute value of a complex number. So we'll start with just in your notes, go ahead and make yourself a coordinate plane that looks just like a normal coordinate plane. Okay, but with a complex plane, remember we're representing complex numbers, so we have a plus bi. So if that's a complex number where a is the real part and b is the imaginary part, on a complex plane, rather than the x-axis, we have the axis where the real numbers go, so the real number part, or the a. And on the y-axis, that's where we put the imaginary part of the complex number. So that's the b part, or the imaginary part. So if I'm graphing 3 plus 4i on the complex plane, that means 3 is the real part and 4 is the imaginary part. So that would be the 0.34. So that just means go to 3, 4 and put a point. Okay, so that's the first part of this problem. Example 1 says graph it. That is graphing on the complex plane. The second part is talking about the absolute value of 3 plus 4i. First of all, what does that mean? What that means is that we're going to figure out what the distance is between that point on the complex plane and 0, 0. So in order to do that, I'm going to draw a line segment connecting 0, 0 with that point 3, 4. Okay, so first of all, this means the distance between 0, 0 and 3, 4, which remember is representing 3 plus 4i on the complex plane. So you learned how to do that in geometry. This distance here, the horizontal distance is 3 and the vertical distance is 4. So we have a right triangle, which you probably remember your special right triangle 3, 4, 5. So we know that that distance is 5. If we didn't remember that that was a special right triangle, then remember we would use the Pythagorean theorem, and we would say 3 squared plus 4 squared is equal to the hypotenuse squared, which we'll call c. So to solve that, if you recall, using the Pythagorean theorem, we want c, so we're going to take the square root. So the square root of 3 squared plus 4 squared is equal to c. So that's how we find the absolute value of 3 plus 4i. We're going to take the square root of 3 squared plus 4 squared. So that's the square root of 9 plus 16, which is the square root of 25, which we already knew a moment ago is 5. So the distance between 0, 0 and 3, 4, which again is representing 3 plus 4i, is 5. In general, if you're looking to find the absolute value of a complex number, a plus bi, and you want the absolute value of that, you're going to take the square root of a squared plus b squared. Okay, now you don't always have to use the graph and the Pythagorean theorem to get it. You can, now that you know that the way we find the distance for a complex number between 0, 0 and that point on the complex plane, the way we find that is using the Pythagorean theorem. You don't have to go through and draw the sketch and use the Pythagorean theorem. You can just use the square root of a squared plus b squared. I was just explaining where that formula came from. It came from the Pythagorean theorem. So if I'm doing the next one here, first of all, I'm going to graph 4, negative 2. So right about there, and that's where the point is. And again, if I'm figuring out the distance from 0, 0 to that point, I'm going to use the square root of a squared plus b squared. So this is equal to the square root of 4 squared plus negative 2 the quantity squared, which is equal to the square root of 16 plus 4, which is the square root of 20, which simplifies to 2 root 5. So 2 root 5 is the answer for the absolute value of 4 minus 2i. Okay. All right, that was it for today in terms of the lesson. Just a quick lesson to talk about the complex plane. Your homework is Unit 4, Worksheet 4, problems 17 to 20. And if you were in class, most students finished that in class. If you were not in class, just do those 4 problems for the next time I see you in class, which will be after Thanksgiving break.